good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to talk about a trigonometry set of problems from Algebra 2. So we're just going to get right to it. So the question says, find the missing values. So first and foremost, you need to understand that this particular, actually, I don't want black. I want a different color. This particular point lies in quadrant 1. So I'm going to go, this is 8, this is 6. So this is kind of like where my point is. My terminal side is going to look like this. And this is going to be my triangle. So I know that this distance of my triangle is 8. This distance of my triangle is 6. And if you notice, this is a 3, 4, 5 triangle or a 6, 8, 10 triangle. So I know that realistically, my circle is going to kind of go like that. So from here to here, my hypotenuse in this triangle happens to be my radius, and that's what this is asking for, 10. Once I have this, I know that my reference angle, or my theta, is always going to be closest to the origin, connected with my x-axis. And from here, I know this is my opposite side, this is my adjacent side, and this is my hypotenuse side. And now I know I can go opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, hypotenuse over opposite, hypotenuse over adjacent, adjacent over opposite. And now I know, and I can fill out all of these particular 6 trigonometric functions, right? So for sine, I know that I'm going to have 6 over 8 or 3 over 4. I could also go ahead right away and simplify all 3 of these into my 3, 4, 5 situation, so that when I put this in here, I know I'm going to end up with 4/5, and I don't have to keep simplifying them over and over and over again. So my opposite is 3, my adjacent is 4. In here, I know that I'm going to have the reciprocal of 3/4, so 4/3. This should not be 8. That should be 10. And therefore, that should be 5 because we want hypotenuse, silly goose. Okay, hypotenuse is going to be 5 over adjacent is 4. Adjacent is 4. Hypotenuse is 3. And that's it. That's how it is. Done with that problem. Let's move on. So now here we're told 2 particular things. We are told that the sine of theta is a negative answer, and we know that sine is opposite over hypotenuse, and we also know that theta lies in quadrant 3. So I know that my quadrant 3 is here. So I'm going to go ahead and I'm just going to draw a random triangle. I'm going to put theta in here. I know opposite is going to be 12, hypotenuse is going to be 13. Whoops. Okay. So once I know that this is 12 and this is 13, I can then use Pythagorean theorem, a squared, b squared, c squared situation. And I know that I'm really missing my b. So I'm going to go 12 squared plus b squared is 13 squared. So really b squared is 196. Nope. 169 minus 144. I think this might also be a triangle, Pythagorean triple. Yep. So B should be 5. Now I know that this distance here is going to be a negative amount. So this is actually -5. This is also going to be negative because this point here is going to be -5, -12. I know that my X and my Y in here are both negative. Okay. So if I'm looking at this and I need to figure out what my X and what my Y are, I know that they're both negative, and I know my X is -5, my Y is -12. My radius is 13. So now I need to go in and fill in secant, tangent, and cotangent. I know secant is the opposite of cosine, so it's going to be hypotenuse over adjacent. I know tangent is opposite over adjacent, and cotangent is adjacent over opposite. So now I can just look at here and then say, hey, my hypotenuse is here, my adjacent is here, and my opposite is here. Should probably write that out. You don't have to write it out. I like to write it out when I explain things. Every single time when I see a negative in my uh, drawing, I'm going to actually bring it over into here. So then I have -12 over -5, which really simplifies to both positive. Same business here. I'm just going to make a reciprocal. And if this original is positive, my reciprocal will also be positive. Okay. Next, I'm told that my radius is 9. I'm told that my X is -2. I know that X would be -2 here. And I'm also told that my angle is in quadrant 2. This is quadrant 2. So I know my triangle will likely look like this because this is 9. It'll be way longer than this 2. This is going to be my theta, and I actually have to find out my y. In order to find that out, I'm going to go again, a squared plus b squared is c squared. And I'm going to have 2 squared or -2 squared, but I don't think that matters, plus b squared is 9 squared. So 4 plus b squared is 81. B squared is 78. Nope, 77. And then I guess b or y is the square root of 77, which is so gross. Let's put that in there. It's a weird looking 7. Okay, so we know that y is square root of 77. Again, I'm going to go in and I'm going to put in here. I have my hypotenuse, my opposite, and my adjacent. In here, I know that the y is positive because this point is going to have a negative x and a positive y in this quadrant 2, right? Always my x is negative here, but my y above the x-axis is always going to be positive. So when I go in for opposite, I'm going to go root 77 over 9. That's going to be positive. Cosine is going to be adjacent, so -2 over 9. Tangent is going to be opposite over adjacent, so root 77 over -2, or just make the whole thing negative is fine. Cosecant is the opposite of sine. So I actually can't have a radical in the denominator, even though I'm taking the reciprocal of this. So I need to multiply by root 77 over root 77 and end up with a disgusting number like, yikes, that was not like this. This is so gross. It's fine though. Okay, secant we know is the opposite of that. So I'm going to have -9 over 2, just make the whole thing negative. And then this is going to be -2 over root 77. Again, I cannot have a radical in the denominator. I need to absolutely get rid of that radical by rationalizing the denominator. And I'm going to be left with this disgustingness. Okay. All right, number the next. So I'm told that cosine is 4/5, and I know that cosine is positive. I also know, or should know, that all students take calculus. This tells me that all of my trig functions are positive. Sine and cosecant are positive in here. Tangent and cotangent are positive in here, and cosine and secant are positive in here. So since my theta lies in quadrant 4 and cosine is adjacent over hypotenuse, I'm going to go in here and create my right triangle with my theta. And I know that 4 is here and 5 is here. I also know that this is another special right triangle, 3, 4, 5. It's a Pythagorean triple. So I know that this point is going to be 4, comma 3. And I know that my x is going to be positive, but my y is going to be negative. Because in quadrant 4, my x's are always positive and my y's are always negative. So my x will stay 4, my y will be negative 3. My radius is always the hypotenuse 5. Cosecant is the opposite of sine, and sine is opposite over hypotenuse. So therefore, I know that this is going to be 3/5. Secant is opposite of cosine, which is adjacent over hypotenuse. And I know that to be 4/5. So I'm just going to make a reciprocal of 5/4. And then this is the opposite of tangent, which is opposite over adjacent. So the flipped version of this would be 5/3. Okay, and there you have it. So essentially, when you're given information, ideally you're drawing the image first, and then you're going in to look for the things that are missing. The last type of question says, okay, use the list below to determine which statement or statements describe the given angle, list all that apply. So we need to first look for reference angles. We then need to determine what kind of rotation it is, and then what type of angle it is, whether it's in a quadrant or whether it's a quadrantal angle. So I believe we will probably have at least 2 things per question. Okay, so let's take a look. 120 degrees actually has a reference angle. We're going to take 180 minus 120 to get 60. So my reference angle is 60C. And the reason why I know that is because I know 120 degrees will end up being here. That means this is my reference angle. And I know that this is a straight line. So I'm going to take this 180 degrees minus 120. I also know that this is a positive angle. So that means I'm going to counterclockwise rotate. I'm going to move in that direction. So that means I'm going to have a rotation of D. I also know that this is not a quadrantal angle. A quadrantal angle is actually an angle that lies on an axis. So examples for, i.e., 90 degrees is a quadrantal angle. 180 degrees is a quadrantal angle. 270 degrees is a quadrantal, right? 360 degrees is a quadrantal angle, and so on and so forth. Okay, so I know that this actually is in quadrant 2, so I'm going to list that this is H. Okay, 315 degrees. Now I know that this is negative, so I know that typically, I know with negative degrees, I'm going to go in this direction. I know this is going to give me negative 180, negative 270, and negative 315 will somehow end up here. So if this is negative 315, I know that this is going to be my reference angle. So that means I'm going to take my full 360 degrees, subtract 315, and end up with 45 degrees for my reference angle. So my reference angle is 45 degrees. That's going to be choice A. In this case, I know I'm also moving in a clockwise position, right? Because my clocks go in that direction. So my angles are moving in this direction. So I'm going to choose E. And I know that it lies in quadrant 1, so I'm going to say that it is G.
270 degrees actually happens to be this angle right here, this portion down here. So it actually is 3/4 of a full circle, right? Because we know this is 0 degrees, 90 degrees, 180 degrees, and then 270. And then finally, we close off the circle, 360 degrees. So this is actually going to be a quadrantal angle. I'm going to put that in right away. Quadrantal angles don't have reference angles, so it will not include a reference angle. So A, B, and C is completely wrong for this particular piece, for this particular problem. And in this case, I also know that I'm moving counterclockwise because it's a positive angle. All positive angles move counterclockwise, all negative angles move clockwise. Speaking of negative angles, this is going to be a clockwise rotation. So right away, I'm going to choose E. I also know that this is going to be 180 degrees. That means my angle is actually not quite going to reach this 180. So this negative 150-degree angle is going to end up here. That means my reference angle is going to be 180 minus 150, which is 30. So reference angle 30, that's choice B. And I know that this is also in quadrant 3. So I'm going to choose letter I. And that's it for these 8 problems. I hope to see you in a later video. Bye.